Hello class, this is for Algebra 1. Chapter 1, Lesson 10. We're talking about word problems. You know, this is everybody's favorite, word problems. I understand that math by itself is hard already, and adding words to it doesn't really make it easier. But after today, I hope that we have a better strategy for how to solve word problems, not world problems. We don't have the time for that. To solve word problems in math. So let's start getting to it without further ado. Okay, let's read this one. We've got Sue who buys a shirt and jeans for $42. The jeans cost $14 more than the shirt. How much does each cost? All right, so before we even get started, what I like to do is I like to think to myself, what do they want me to do? What is the question asking me to do? And if I go back and I read this section, it will tell me what they're asking. Sue buys a shirt and jeans for $42. Any question in there? Not yet, just statements. The jeans cost $14 more than the shirt. Any question in there? No, but there is a little bit of a mystery, right? The jeans cost $14 more than the shirt. We don't know how much the jeans cost. We don't know how much the shirt costs. There's a mystery in there. The last line, how much does each cost? Okay, so there's the question, right? How do I know that? One, there's a question mark, so that's always a giveaway. And number two, they're saying how much does each cost? Now we've got to identify what do they mean by each? Well, there's only really two things in this scenario. We've got a shirt that's been bought and a jeans that's been bought. Okay, so let's write down some of the steps. Step one, what are they asking for? What is the ask? In this case, we need to find out the cost of each item. How much do the jeans cost? And how much does the shirt cost? That's the ask, okay? We're looking for J and we're looking for S. We're abbreviating those, okay? So that's first. The second thing we did is we identified the items, the jeans and the shirt. So technically now we're on to the third, but for this, step two is, what information do I already know? I like to call this step, state the facts. We know what we're looking for now. Now we got to do what a detective would do, and we have to look around for the facts. What are the facts? One, Sue bought something. She bought two things, in fact, a shirt and a jeans. Both of those things put together cost $42. How do I know that? It says it in the very first sentence. She buys a shirt and the jeans for $42. So what I know for a fact is that the cost of the jeans added to the cost of the shirt must equal $42. That's one fact. The second fact, but what I'm going to do is I'm going to color code everything. So I'm going to color code the shirt as green, the cost of the shirt as green, rather, so that I know how to differentiate between the jeans cost and the shirt cost. The next thing I know for a fact is that the jeans cost $14 more than the shirt. So what does that mean? The jeans, J, are always equal to whatever the price of the shirt is plus $14. How did I know to create that equation? Well, I literally just spoke out the facts. The facts were that the jeans, which are J, cost more, and in this situation, the value is whatever the price of the shirt is. How does it say price in that sentence? Well, it just says cost $14 more. That's more of an English thing, right? You just need to know that cost $14 means the price of something is $14. Well, in this case, it's the jeans is whatever the price of the shirt is plus $14. So that's my last fact. So with those two pieces of information, I should be able to contrive to create some type of equation that answers both questions. I have what one of my variables is, and one of my variables is the jeans. And the jeans relationship is that it is always $14 more than the shirt. So now my next step is, since I know, step 3, since I already know what one jean cost, I don't actually know the physical dollar amount, but I know how to find it, right? I can now take my jeans, which is equal to the shirt plus $14, and substitute that value in to my original equation. My original equation was the jeans plus the shirt price equals $42, right? So now in this equation, I can replace this jeans with what that jeans is worth. And if I replace what J is, it is the shirt price plus $14, and then I just fill in what's left, plus the price of the shirt is going to be a total of $42. So there's my new equation. Now all I do is I get rid of the parentheses, because that's what stood for J. I add like terms, the S and the S. That gives me S plus S. That's how many S's altogether? That's 2 S's, S 2 times. I drop my $14, my positive $14. I drop my equal sign. I drop my $42. And now I do the inverse operation of adding $14, which is subtracting $14. What I do to one side, I do to the other. Then I solve this out. So now I have 2 times the shirt value is going to be equal to this new total, which is 42 minus 14. 42 minus $14 is what? 32. 32 minus 2 is 30, minus another 2 is 28. So $28 is equal to 2 times the value of the shirt. I'm going to rewrite that over here. So 2 times S is equal to $28. I now need to get rid of this 2 in front, so it's a 2 times S, so I need to divide by 2. What I do to one side, I must do to the other. 2 divided by 2 is 1, so that's going to get rid of that. So it's going to be S is equal to 28 divided by 2, which is 14. The cost of one shirt is $14. All right, so now that I know that, I take that information and I plug it back into what I already know. Because I know that a shirt is worth $14, I can now replace my shirt value that I didn't know in one of the equations. So I'm going to replace it in the equation that says that a jeans cost is equal to whatever a shirt costs plus 14. So here it is. I'm going to erase these to get some space. I know now for a fact that my shirt value is $14. So I replace that equation. I can do it with either one, but I'm going to do it with the jeans one, the jeans equation. It's also $14. So the cost of jeans is whatever the shirt cost is, which is $14, plus another $14. So altogether, 14 plus 14 is what, 28? A jean or jeans cost $28. Now I should be able, well, hold on. A jeans cost $28 and a shirt costs $14. So now I should be able to take these two values and plug them into my very original equation, which says whatever jeans cost plus whatever shirt cost should be $42, because that's how much Sue paid for both. So all I do is I replace my J with its value, which is 28. I replace my S with 14, and I say, all right, Does 14 plus 28 equal 42? This is how I prove it. Well, 28 plus 14, 8 plus 4 is 12. So far, so good. 1 plus 2 is 3. 3 plus 1 is 4. $42 does, in fact, equal $42. I'll color code it. Therefore, my answers are correct. A jean costs $28 and shirt costs $14. We have found the answer to each. So I go back to my step one and I say, all right, did I find the cost of the jeans? Yes, I did. Could I prove it? Yes, I could. Can or could. And what is the cost of one shirt? $14. Because if you buy one shirt and one jean, they will both equal $42. Hopefully that was helpful. If you have time, continue to watch this video, and I will do one more, and I'll do it nice and slowly. But if you understood what we did there, go ahead and get to your assignment. All right, for those of you who are staying, let's do a very simple one. Products of integers. So the question asks, the product of two integers is 32. One of the integers, sorry for the tapping, is twice the others. What are the integers? All right. So my first step is always asking, what are they asking? Step one. What's the ask? The ask here is we're looking for two integers. The product of two integers. One integer is twice the others. That's not a question. The question is, what are the integers? So we're looking for two integers. We're looking for essentially some value for x, some missing number, and some other missing number y. Why did I pick x and y? I just chose random letters to stand for things that I don't know yet. Okay, that's it. Next, I start to talk about the facts. Step two, what are the facts? Find the facts. All right, let's start at the beginning. The product of. Anytime I see the word product in math, I'm going to think multiplication. The product of two integers. Do I know what my two integers are? Nope. All I know is one is going to stand for x, and the other one will be y. That's all I know. So I know that their product is 32. I now also need to know what an integer is. An integer is any negative whole number, -3, -2, -1. 0 could be an integer, 1, or any positive integer, 1, 2, 3. Right? So I'm looking for a whole number that's either negative or positive. Those are integers. Their product has to be 32. So what's the first fact I know? Whatever x times y is, whatever those numbers are, the answer has to be 32. Okay? Another way you could have written that is x, y. And again, you didn't have to choose x or y. I just did because those are the most common variables. Okay? Either way, they have to equal 32. What else do we know about these things? Well, we also know that one of the integers is twice the other. Twice is one of those special English words that means 2 times the other, right? So I have to pick one of the integers. I'm just going to pick the x, right? I know that, well, I don't know this, I'm just assuming, just for the sake of solving the problem, that one of them, and I'm going to choose x, is 2 times or twice whatever the other one is. So if y is 1, x is 2 times 1. If y is 3, x is 2 times 3. It's always twice the other one. Okay? So now I have enough to figure out my problem. Why? Because I have these two equations. So now I try to solve the equations. Do I know what one of the variables equals? I do. I know what the x equals. The x is equal to 2 times whatever y is. So in this original equation, I replace what my x is with what I think its value is. And what I think its value is, according to what they told me, is whatever 2 times y is. So I replace this x with a 2 times y, and I still have my multiplied y would equal 32. I've used what the value of x should be to replace x in the first equation. So now I'm going to solve that up here. 2 times y, which is really the substitute for x, times y is equal to 32. All right, so now I say to myself, is there anything I can do to combine these? Yes, I can. 2 times y, or 2 times y times y. How many y's do I have there? Multiplied by each other? I have 2. So that becomes 2 times y squared. And that's going to equal 32. Then I need to remove this 2 by dividing, because it's multiplying, so the inverse is dividing. 2 divided by 2, 32 divided by 2. I get y squared is equal to 32 divided by 2 is 16. Now to get rid of a square, or a power of 2, I take a square root, and a square root to the other side. What I do to one side, I must do the other. This cancels out the square. This turns into a regular y equals, the square root of 16 is 4. How do I know that? Because 4 times 4 is 16. Square root of 16 is just 1/4. So my y should equal 4. If that is true, when I plug y into this problem here that says x equals 2 times whatever y is, x should be then 2 times 4. X therefore is 2 times 4, which is 8. So my x should be 8, and my y should be 4. And if I plug those two back into my original equation, I should get 32. Let's see if that's true. I'm going to erase all this to get me some space. And so I test it. The product of two integers, x times y, should give you 32. One integer is twice the others. Well, if the integer for y is in fact 4, then the other integer should be 2 times 4, or twice 4, which is 8, is what we said we had. Let's see, is 8 times 2, 32, 8 times 4, 32? Well, let's see, 8 4 times. 8 plus 8 plus 8 plus 8. Does that equal 32? 8 plus 8 is 16. 8 plus 8 is 16. 16 plus 16 is 32. Ladies and gentlemen, we have liftoff. Your answers are y equals 4 and x equals 8. So I hope that helps. Remember, step 1 is always find what are they asking for. Step 2 is always identify the facts and try to translate them into an equation. Step 3, solve for your missing variables. All right, that was lesson 1.10, solving word problems. We'll see you in the next video.